Hey everyone, and welcome. So if you're an ABAP developer and you're kind of looking to make that leap from the traditional procedural way of doing things into the much more modern and powerful world of object orientation, you are in exactly the right place. Okay, let's get right into it and totally transform how you think about your code.
Does this sound familiar? I mean, this came from a fellow developer over on Reddit, and wow, it captures that feeling perfectly, doesn't it? It is so easy to stick with what you know, that old, faithful procedural way. Because, it's comfortable, it works, and let's be real, deadlines are a thing. But that comfort zone, that's exactly where you can start to feel left behind.
And we've all seen it, right? Maybe we've even written one. That one giant program, the monster that does everything. That massive, sprawling report that's thousands upon thousands of lines long. It probably started out pretty simple, but then over the years, it just grew into this beast that's almost impossible to understand, let alone try to maintain or add something new to. That, right there, that's the pain that tells us it's time for a change.
So let's just call it what it is, the procedural predicament. And look, this isn't about saying the old way is bad or anything like that. It's really just about understanding its limits, especially as our applications get more and more complex.
Yeah, and this is the real trade-off, isn't it? In the short term, hammering out some procedural code can feel super fast. You just start at line 1 and write out the steps. But the long-term cost? It just creeps up on you. The code starts to look different all over the place. Fixing a bug over here somehow breaks something way over there, and trying to scale it for new requirements becomes a total nightmare. We're basically trading a little bit of speed now for a whole lot of pain later. So how do we break out of this loop? Well, it starts with a pretty fundamental shift in how we approach our programs. We have to start thinking in objects. And this isn't just about learning some new syntax, not at all. It's a completely different, and I think you'll find, a much more intuitive way to think. At its heart, object orientation, or OO, is actually a beautifully simple idea. Instead of just writing a long list of instructions, you start to create objects that represent real-world things. Think about a sales order, or a customer, or even a material in your system. Each of these things becomes an object that holds its own data, and, this is the key part, it also knows how to perform actions with that data. It's just a much more natural way to organize all that complexity. And this is a fantastic way to picture it. Think about a car factory. The factory itself, that's like a class. It's the blueprint, the plan for how to build a car. Now, a piece of data, like the total number of cars the factory has ever made, that belongs to the factory, right? Not to any one car. That's what we call static, or class-level data. But every single car that rolls off that assembly line, that's an object, an instance of the class. And each one has its own unique mileage, its own color, its own VIN number. That's instance data.
All right, so to really get this new mindset, we have to understand its foundation. Object-oriented programming is really built on 3 main ideas, or pillars, that all work together to help us create code that's super robust and flexible. Let's break them down, one by one.
Okay, first up, encapsulation. The easiest way to think about this is like creating a protective bubble or a capsule. You wrap up the data, like our car's mileage, and the methods that can change that data, like a drive method, all together in one self-contained unit. This is huge because it stops other parts of the code from just reaching in and messing with the data directly. It's all about security and cutting down on weird, unexpected bugs.
And how do we build this bubble? Well, ABAP gives us these 3 visibility sections to control access. Anything public is like the front door. It's accessible from anywhere. Private stuff is locked away in a vault. Only code from inside that exact class can touch it. And protected is kind of the middle ground. It's accessible by the class itself and also by any subclasses that inherit from it. It gives you really fine-grained control over your object security.
Pillar number 2 is inheritance. Now, this is where the magic of reusing code really starts to happen. Inheritance is all based on what we call an ISA relationship. For example, a salaried employee is a type of employee. So instead of building that salaried employee class from scratch, we can just say it inherits all the common stuff, like name and ID, from a general employee class. Then we only have to add the special logic, like how to calculate their salary.
And this diagram just shows it perfectly. You've got your general employee superclass at the top, defining things that all employees have in common. And then branching off from that, you have specialized subclasses like hourly employee and salaried employee. They get all the common stuff for free, but then they add their own specific ways of doing things like calculating wages. We're building on what's already there.
not rewriting it every time.
And our third and final pillar is polymorphism. I know, it's a big word. It literally means many forms. But the concept is so powerful, it makes our code incredibly flexible. Basically, it lets us write code that can work with a general type of object, like our employee. But then at runtime, the system is smart enough to call the specific version of a method for whatever subclass it's dealing with. So you can send the same message, like calculate_wage, to all your employee objects, and each one will respond in its own correct, unique way.
And here we go. This is it in action. This is actual output from a simple ABAP program. The programmer used the exact same method call on two different objects, but one object knew it was an apple, so it said, I'm a fruit, and the other knew it was an onion, so it said, I'm a vegetable. The main program doesn't have to care what they are. It just sends a generic message, and polymorphism takes care of the rest. It's so elegant and so powerful.
Okay, so that's the theory. Theory is great, but it's not super useful if we can't actually put it into practice. So the big question is, how do you actually start making this change? How do you go from writing those long procedural reports to building objects?
Honestly, don't overthink it. Joachim Ries from the SAP community shared this fantastic, super simple checklist to just get the ball rolling. Just follow these 6 steps. You create a class, give it one public method. Then you create an interface and move that method to the interface. And finally, you set up a test class. This simple little routine forces you to get into the habit of thinking about things like public contracts and testability from the very beginning.
And please, remember this. This is a golden rule. Before you just jump into the editor and start writing code, just take a minute. Pause. Think about the objects you're going to need. What data will they need to hold? What actions should they be able to perform? I promise you, a little bit of design work up front will save you a massive amount of headaches and refactoring later. Your future self will definitely thank you.
Okay, let's bring this all home. Because when you really embrace this shift in thinking, you're not just writing code anymore. You are actually crafting a development masterpiece. But first, let's clear the air on one very common objection.
I'm sure you've heard this myth before. Oh, object orientation is slow. The reality is, that's a really outdated excuse. Most of the time, performance problems in ABAP applications come from inefficient database access. You know, bad select statements, not using indexes, that sort of thing. A well-designed OO program is not automatically slower. In fact, because it's so much clearer, it can often make it easier to find and fix the real performance killers.
So ultimately, the goal is this. Moving to object orientation is about elevating your craft. It's about taking pride in what you build. It's about creating solutions that are more than just functional. You're really aiming to create your own artwork, code that's efficient, that's strong, and that can easily grow and be maintained.